So yeah, in the last one I was talking a lot of smack, and I stand by it, but at the same time, there was a problem. And I just saw it. I saw it while I was, I came up with it while I was reviewing. But yeah, we'll come over here to, oh, and that you can hear the, rain outside is hitting my, air conditioner. So that's what that sound is. Anyway, so over here at language, remember it's been on 14 standard, right? Hold on. This thing shouldn't be running. Let's see if this runs. X. Let's try it again. Cannot proceed because the DLL wasn't found. Anyway, earlier it wasn't working, but then I changed it to this. I changed it to this. Somehow it went back to that, but I changed it to 17 because remember when we were downloading SDL or whatever it was, SFML, it said something about 17. So apply that, okay, and then when we run it, this happens because we don't have the DLL wherever it should be. So that's what we're going to do now, is we're going to find the DLLs and put them where they need to be. I think it needs to be like right next to this thing. So we're going to figure out how to do that. And I don't know how to do that. Oh, pardon me. I'm just looking up here and I don't know what to press. Maybe it's down here. Maybe it's something to do with let's go to C. Is this C? No, this is desktop. All right, here's this. So here's some DLLs here, but I don't think that has anything to do with it. Here's SFML. Let's go see if we can find any DLLs around here. Libs, a bunch of libraries, but no DLLs. Nope. CMake? No, I don't think so. Include? Does this have DLLs in it? No, I don't see any. So down here we can see kernel thing symbolized what? I don't know what any of this means. A dependent DLL was not found. What does that mean? Let's go ask ChatGPT. Let's do this right here, and let's say let's attach that. Let's go to where's this located? Oh wait, hold on. Desktop C++ projects, game engine. Desktop, where you at? C++ projects. Where was it? Game engine? For real? Game engine, okay. It needs to be somewhere else, but whatever. SFML test. Alright. So it's right in here. I don't know why it's there, but we'll fix that later. So here's this is. Let's. No. What am I trying to do here? Nope, that's not what I'm looking for. I'm looking for this file right here, the main .cpp. I guess I could keep looking. SML, okay, here. Oh, right here. All right, open. So when I run this, I get this in the output. This will probably, we'll see what happens. Require DLL. Okay. I hate it when it's all that text. All right, but whatever. The error message we're encountering indicates that required DLL files not found. It typically occurs when SFML dependencies are not correctly set up in our environment. Here's some steps to resolve this. Ensure SFML binaries are in the path. Make sure that the SFML binaries are in a directory that's included in our system's path, or that they are in the same directory as our executable. Yes, they are not, but we know how to do that. Check if the version. Okay, so we need to do this right here. To help with the first step, we can add the SFML bin directory to our path. SFML bin directory to our path. Let's go check that out. This one, and then C, SFML. Let's go look at the bin. Boom. Ah ha ha, there we go. Yeah, copy them. I just press Control C, maybe that'll work. Let's go back to Game Engine, SFML test. I think it's in here and in here. Oh wait, we need to. I need to get the dot whatever's properties. Hidden, sharing, security, sharing, previous version, customize. How do we get the .exes to show up in the File Explorer? How do we get the file extensions to show up in the File Explorer? View. There, I see the view right there. Show hide next to file name extension. View. Boom. Cool. Okay, there's the exe right there. Cool. So now that we've done that, let's push Control V. Haha, there we go. Cool. Now let's run it. Let's do it big. Haha, right. Okay. Whatever. Hey, look. I'm stand by my smack talking earlier. You can't back down. But yeah. I know it works. Okay. All right. So let bygones be bygones. Hold on. Cool. Okay, so we got SFML working over here. So I'm thinking hold on. Maybe I was a little harsh to the guys. Look, you gotta understand, I'm a hot-blooded guy. and I get a little bent out of shape. I don't mean nothing by it. Thanks for the work, my boys. All right. So that being said, so now we're in business. We've got something on the screen when we run this. Okay. So now we can start making something happen. Okay. So window.clear. What the hell happened with this? What is this? Clear the entire target with a single color. Window.draw shape. Window display. If event is closed, window.close. Okay, so this is it. This is what happened. We did this and something happened. So we got to figure out what's going on. Let's start at the int main. SF, render window. And this is, okay, let's start here. Include SFML graphics.hpp. Okay, so we're doing that first. And that's after we slapped it. We changed this to 17. Also, general. We added this include file path from over here. Right here. It's this one. And this one, include here, and then lib for the other one. So here's the include, and then we've got over here on linker. Oh, come on now. We've got this one, okay, and then we've also got in linker input these right here, because these are hold on. These are these SFML graphics lib window and system graphics window system. All right, and then there's also network and audio whenever we feel like fooling with that stuff. But there we go. So we got that. So those are the 4 things we changed inside of the properties, and then we just got this off of the site, which is right SFML here. We just went down here and we got it off of this one, the one with C++ 17 right here. All right. And that's it. That's it. So that's where we're at right now. Maybe there's more to that tutorial. Maybe we can get some more actual info out of it. So let's go check it out, huh? How about that, huh? Visual Studio. Yeah, I was harsh on them, but you know what? That's what I say in my frustration. I'm walking it back now. If you got a problem with that, well, tough. So here we go. And there's the static. We didn't do that. We did the dependencies thing. All right, cool. I mean the DLL thing. All right, so we got this and we got that. All right. All right, so the next thing is none of this stuff. Okay, so we got it started. Let's go to system. Angles. What? Okay. Okay. Let's see what this says. Okay. Angles, handling angles in SFML. This represents an angle in a unit agnostic manner. Okay. So that we can reason about angles in terms of degrees or radians. Okay. I think they're talking about angles. Now that I see degrees and radians, because those are some math terms. I went to math at one point in my life. SFML defines angles as following the right-hand rule. I don't know what that is. Let's go see real quick. Oh, in mathematics and physics, the right-hand rule is a convention and a mnemonic utilizing the M is silent. It's mnemonic utilized to define the orientation of axes in a three-dimensional space and to determine the direction of the cross product of two vectors. Of course, why not? As well as to establish the direction of the force on a current carrying conductor in a magnetic field. Obviously. What? I don't know what that means. You know what? Break this down so a dummy knows what it says. Break this down for a dummy. Boom. What it is. Oh man, that's not really it either. That's way more words. ChatGPT doesn't know what a dummy is. And you know what? You know what? That's why AI is not taking over. Because how's this for a dumbass? You know what I'm saying? Or is it like this is the compressed version and this is what it all, when you fluff it out, this is what it looks like? I don't know. We'll see what it says. What is it? The right-hand rule is a simple way to remember how certain directions relate to each other in 3D space. Oh, it's like a memory aid or a shortcut used in math and physics. When it's used defining axes. It helps us figure out how to set up and label the three axes, like X, Y, and Z in a three-dimensional space, okay? Cross product or vectors. Okay, we're actually going to need to know what this means, so let's keep reading it. Cross product of vectors. When we need to find the direction of a new vector that is perpendicular at a right angle to two other vectors. Whoa. When we need to find the direction of a new vector that is perpendicular at a right angle to two other vectors. The right-hand rule shows us which way the new vector points. We are going to need to know some math to do this crap, huh? Magnetic force on a conductor. I don't think that has anything to do with us right now. I think it has to do with this. How to use it. For axes and cross products. Point our right hand's fingers in the direction of the first vector, then curl them toward the second vector. Your thumb sticking to the... What does that even mean? Okay, what does that even mean? It's the cross product. It's the cross product one. Or axis one. The vector one. It's the vector one. And also, what? How's this relate to SFML? Boom. In physics and engineering, when we have two vectors and we need to find their... Whoa, hold on. You know what? What's a good question? What's a vector? I could have sworn a vector was something that I don't remember what a vector is at all. All right, what's a vector? What's a vector? Graphic vector. In computer graphics, a vector graphic is an image created using paths, lines, and shapes defined by mathematical expressions. Okay, unlike raster graphics, which are composed of pixels, vector graphics are scalable without loss of resolution, making them ideal for logos, fonts, and any graphics that need to be resized frequently. Oh, I think it's actually a mathematic vector now that I still look at that, because This is for graphics. All right. In mathematics and physics, a vector is a quantity that has both magnitude, size, and direction. Okay. It's often represented by an arrow where the length of the arrow indicates the vector's magnitude and the direction in which it points indicates the vector's direction. Vectors are used in various fields to represent physical quantities such as force, velocity, and acceleration. I can almost understand when it says magnitude. What does that mean? When you say magnitude, what do you mean? Because I'm thinking mass, but it can't be that. Magnitude refers to the length or size of the vectors, not mass. It essentially measures how much of the quantity the vector is representing. For instance, if the vector represents velocity, the magnitude would be the speed, which is a measure of how fast an object is moving, irrespective of its direction. Magnitude can be calculated for a vector given its components. For example, in a two-dimensional space, if a vector has components x and y, its magnitude can be calculated using the Pythagorean theorem. Okay, x squared plus y squared equals magnitude. What? But it's the square root of that. Equals c squared? So this would be c? What in the world? What in the world? What are they talking about? What is this? I've seen the Pythagorean theorem. It's something about the triangles, right? But this is, what are you talking about? We're going to need to figure this out. I think we need to know about vectors. We're at 22 minutes. We can figure out vectors. All right, let's go to real vectors. Vectors explained. Yes, video. Yes. I need to put on my headphones. All right, let's go. I'm gonna watch this whole thing. I'm gonna get so smart. Hopefully it's not that much. I like it.
And welcome to High School Physics Explained. Let me start by asking a question. What is 3 plus 4?
7.
Now the quick answer, of course, is 7.
True.
You're making a number of assumptions here, of course. 3 plus 4 are two simple numbers that are integers, and you're adding them mathematically. But what if I asked you, what is my displacement after I initially work 3 meters and then 4 meters? Clearly now,
I don't know
my
what displacement
answer
is.
may not necessarily be 7. For example, assuming I walk initially 3 meters like so. I now walk another 4 meters in this case, and clearly my displacement is now 7. But what if I walked 3 meters like so, but then I walked 4 meters in the opposite direction? Well, now my displacement is only -1 meter.
Say what?
He loves that baby.
My pride and joy.
Okay, chill out.
But what if I walked initially is only -1?
Hold on a second. Okay. Okay, let's keep going. Well, I don't know what the point of this is. Let's go.
1 meter in this direction. But what if I walked initially 3 meters like so, and then I walked 4 meters in that direction? Well, now my displacement is 5 meters.
Displacement.
Last example.
What does that mean, displacement?
Again, I walk 3 meters initially in that direction, and then I...
Is he talking about how far he is from the original point where he was standing? Is that what displacement is? I bet that's what it is. I bet that's what it is.
Decide to walk 4 meters in that direction. Again, I'm going to get a different value.
Yeah.
So in each case, I'm going to get a different value simply because we need to take into account the direction that I'm traveling.
True.
As a result, as I often said to my student, the most full answer here can be any value from -7 to 7. My displacement can be any value as long as I also know a little bit about the directions that each component has.
True. Because he could go this way. You could go this way 7, or you could go backwards 7, which is the negative. I don't know why that counts as negative. I would just think it would be all the same, but whatever. Let's go.
So what I'm introducing here is the concept of vectors. What
Sure.
are vectors?
What are they?
Vectors are any measurable quantity or dimension that has both a size and direction.
Hold on a second. So this has to do with direction and size.
Any value.
Hold on. What? Okay, I get it. So he walked in. The NPC went that many pixels to the right. So that's the vector, is the traveling distance, I imagine? And the fact that it went to the right? I think that's what they're saying. I think they're saying, like, let's say we have like some squares. Can we make some squares? I know where some squares are. Check it out. I know exactly where some squares are. Check it out. Also, this game, I don't know. It just doesn't feel good. I don't like it as much as they're saying it's good. I don't think it's that good. Because I'm a Sombra player, number one, first and foremost. I'm a Sombra player on Overwatch, and they don't have anything anywhere near Sombra. And I just can't get into it. Sombra's the best. So yeah, I think that's what it is. Like, let's say, let's come over here. Let's open up projects, checkers game, this one, and let's run it. So let's say the vector would be, let's move this to here. So that's the vector. It went from here to here at, I guess, 45 degrees or negative 45 degrees or something. And it went that many spaces. So that's the vector, is from here to here. That's the vector. You get what I'm saying? So let's run with that. Let's say that's what a vector is these days. All right, let's go back over to the thing we were just doing. It was in game engine, wasn't it? Yeah, it was. Whatever. All right. So that's what the vector is. And now we are back to this. Because we're anyway, so that's where we are right now. It's about 29 minutes on the thing. On the time right now. But that's where we are on SFML. We don't really need to know angles, right? I guess we do, because we're going to need to know, we're going to need to like do the circles, whatever, you know? Also, we haven't even looked at this code yet. Like, what's going on? Why did this do this? Why is it a circle like that? Why is it green? Is this just the default, you know? Is this default shape? It can be anything. Draw shape. Oh, here's the color right here. And here's the ooh, circle shape. Oh. Anyway, so here we go. This thing works. We're 30 minutes in already and we didn't even do anything. But that's what happens when you're coding with Code Man S. Whatever. I don't look. Look. Include SFML graphics. Okay. Int main, render window. That's the window. Okay. That's this window. We could make it bigger. We go 800 by 800. Save it and run it, and now we've got it bigger, but now it's over here. So we can fool with this. All right, and then now we got the circle shape here, but I don't know how the oh, and look, SFML works. Also, what is this? Okay, so this has to be the diameter right here because it was a. Okay, so let's make the diameter 400. Save it. Now let's run it. Yeah, see? Okay. Also, this color sucks. Let's make it a better color. Let's make it brown. Better on the eyes, I mean. Brown. How about it? Save it. Let's see if it works. Nope. All right, so that didn't work. Oh, why? Because I didn't do it right. No. Why does green work but brown doesn't? Blue? I guess blue works. Okay, let's see if that works. Yeah, it does. So what other colors are there? How do we pick a color? Can we just... Okay, hold on. We'll figure all this out. In fact, I think we should just start from here, and then import the. We'll get the logic and bring it over to here. You know what I'm saying? So that's the next step. All right. So we're good. We're good right now. We're good. We'll figure out this vector stuff when we need to, but we're good right now. We can figure out what's going on with this. So in the next one, we're going to use this to make our board. We'll get ChatGPT to do it for us. All right, so there's that, and we'll see you next time.